So, welcome to our cylinder and valve design guide. As it says, we've got a cylinder and we've got a valve and the pipework, and you have to look at the whole system when you're calculating its performance, checking its performance. And we have a nice force balance diagram that actually helps you visualize what's going on. It shows you the forces from the loads. This gives you an idea of scale, and the forces provided by the bore in the annulus, so you can scale things up, and provided it meets here, we have a balanced system. So just to show you, if we were to drop the pressure, what you'll see is that at some point you don't have enough pressure to drive the load, and so we have a break here, and that's wrong. But it's a nice way to visualize this, and makes it easier to design a system, makes it easier to check through all the situations, all the load conditions, see how it's going to work. So if you're an experienced designer, you can potentially cut down your energy losses and make a more efficient system, because you can highlight the issues in the areas where you can have higher energy losses and power wastage. If you're a beginner, if you're not used to designing many systems, then this takes you through each section. So we've got our supply section, our load section, the cylinder data, the valve data, and the pipework data. So it takes you through everything you need to know or may need to know in a system, so that you can give you a bit more confidence in designing. So what this is actually, it is a simulation, but it's not a full, really dynamic simulation with the likes of AmaSim and such. But there, you have to be skilled. You have to put the right data in to make them work. So this is a little bit more idiot-proof. You can only put in certain values, so you can't get things. Well, you can still design systems that won't work, and if they won't work in real life, they shouldn't work on here. But it's not so security-proof. What you can see actually is, as we change things, the program is actually calculating in it, and it goes unstable until it gets there. So it's really an Excel spreadsheet. Imagine you've got all the values in an Excel spreadsheet, and that spreadsheet is looping continuously, so it's changing its own values based on the results from certain calculations. So it's looping 50 hertz, 50 times a second, but it still can go unstable. Just a little note, if it does go unstable, we've got a little gain amplifier here to stabilize things, which you might need in if you're in proportional. But let's start and let's go through our different sections. So we start with our supply. Now clearly you can have a pressure compensated system, you can have a fixed displacement pump. They will be different, so you have to think a little bit about what your system is. If it's pressure compensated, then the pressure just stays stable here, and the excess flow goes through the relief valve or pump compensator. So this flow is the supply flow, which should really be higher than you need, but certainly if you change this flow, it does not change the speed of the system, because the speed of the system is set by the control orifices in the valve. So this is our supply flow. But again, if you've got a fixed displacement system, then you may find that what would happen in your system is, as you operate the valves, then this may control the flow and the pressure come down. So don't treat the system as completely foolproof. You have to think a little bit about your supplies. What we also have here is an angle of the cylinder. Now this is making our calculations easier. If your load is changing angle, you can test it under the different conditions. And of course, if we've got mass, that works against friction, so at 0 you'd have no friction in the calculation. But if you had it horizontally, all the mass would act as friction and inertia still. So you can split your loads up into mass effect, force effect. You may have a force. This is really if you have a force with no mass, say from a clamp or from another hydraulic cylinder or something putting load on. So sometimes you can get no mass but still have a force. And we've got a frictional parameter here as well. You may have noticed that as we change the angle, that it automatically selected a new cylinder size, because it's trying to predict what cylinder you need for the various loads. That's fine to start off with and to get roughly in the area, but then lock it down, because you can't predict what's happening if the cylinder size keeps changing all the time. So as soon as you know roughly what your cylinder is, click this and that will lock it in place so it doesn't change. A bit more, we've got some edit buttons here which bring up a new panel with some more detailed information in. So in this case, on the supply side, we've got the maximum loads that we can generate with this pressure, and we've got the maximum flows that we could, the maximum speed of cylinder that we could have if we used all the flow. So that's additional information, and here, going on to the next section, we have our load data. So as we can see, if we change the mass changes. Our force, we're going to change the force. We can go positive or negative on the force. And friction is changed in here if you need to. It may be that you've got a very frictional, fully frictional load. Another important factor, well, to look at, we've got a box to describe the load, because loads are incredibly important, and if you're going to send your information away to get a quote, then describe the load, the conditions, the environmental conditions, any shock loadings, anything that happens, as much information as possible, and that will help the person designing or specifying the equipment to get the right components. Also, we have a mass lever ratio, which is really important. I mean, if the mass is just sitting on the cylinder, then keep it at 1, but if you have got a lever system, it's really quite important to know what that lever ratio is for the mass, because that affects not only the loads on the cylinder but also the dynamics of the system and the natural frequency, which we'll come to later, but you do need to specify that, and if you can't get the slider to the value you need, then just type it in. Finally, down here we've got the stiction. So cylinders will have a seal friction, typically 3 to 4 bar, but if you've got a load that is particularly got a lot of stiction and friction within it, not affected by mass as this one is, then you can add that value in here. So you should be able to define quite a comprehensive load to get as close as possible to your own load. So next we come on to the cylinder data, and as I say, you can select the cylinders you require, you can select your stroke that you have on this cylinder, and importantly you can select the type of mounting. Got a range of options here, but if you select that, you can see here and here you've got the excuse me, you've got the it shows the type of mounting you've got. So this is just body feet mounting, and you can actually have supports for your rod as well. Now this gives us some more information. This typically just the cylinder information, but here we've got the maximum stroke available. So for this type of cylinder, manufacturers may be different, but they're going to be around this. Obviously check the data sheets if you've got particular cylinders in mind, but it gives you an idea of what your limits will be. And the force available, maximum force allowed. So with the different types of system, you can see if we change them, the forces change. So rod buckling is potentially going to be one of the areas where it limits your design. You might need to use larger cylinders just to start rod buckling, and this will tell you what you can achieve, what force you can achieve in this design of cylinder, and this will tell you the maximum length that you can go up to before buckling occurs. So they're nice information, and obviously as you change the pressure and things, these well, they don't change, but as you change your conditions and it changes these values. You can also here put in your actual free buckling length, and it will tell you what load you can go up to, which is just quite nice compared to scanning through the data sheets, but easier to use. So that's our cylinder data. Next we have the valve data. So we can choose the type of valves we require. We may need have no control at all. So here we've got no orifices in our valve, and if we look, that works perfectly for extending the cylinder. Nothing wrong with that until you try to retract it. So moving your mouse over this valve or selecting the valve, you can change the way the loads are working, the graph, what the graph shows. So here we are retracting at a very quick speed because it's collapsing, and we really don't want to do that. And you can see here that we've got a gap there, so it's not balanced, and as we know, we never want to use valves with no control orifices in or no flow control, because the cylinder will just collapse. We've got our meter out that we used to make it work. Oh, it's still not working even with that. We've got our meter out there, we've got a meter in, there's another option, and we've also got proportional control. Proportional, as I say, can take a little time to go stable, so you've got your gain value below just to change things, but if you change, you can see with a proportional 1-to-1 spool now we've just got two orifices that are the same size. If we switch to the 2-to-1, we get a larger orifice on the bore side because we're taking more flow. And if we come back to our meter out, on a meter out, of course, we've got our check valve. So this is the size, excuse me, of the check valves as the flow comes back through them. Sizes aren't particularly important. On a system, you'll just adjust it and not know what the sizes are, but they're quite useful for knowing what size you're using compared to the size of the valve. Quite often, proportional servos, people put in too large a valve, which is not good, and so it gives you an idea of what you need. Okay, finally, racing on, we've got our pipe data. So what we've got here is you can put in the fluid velocity that you require, and that sizes your pipe work, gives you a rough size of pipe work. And we have a pipe length, and this calculates the natural frequency. The natural frequency is important really for any proportional or fairly dynamic systems you want to control well without knocking, because what can happen with a system, if you come down below your minimum acceleration time, which is calculated from the natural frequency, then you get overshoot. So as you open a cylinder, it will go bang, and you'll get a bit of a jump and a bit of a judder, which quite a lot of the time is fine. Sometimes you want to control that, and this is just a nice, quick and simple way to give you an idea of what region you are in. Effects by pipework. If you had too long a pipework, 60 meters, then you would drop into our red zone here below 3 or 4 hertz, and you'd get some oscillations, and it would really judder. And so you need to be away from that region. We've got a whole second here acceleration time. Typically, you quite often find systems come around about 10 hertz is not unusual. If you're building more dynamic, higher performance machines, you'd be a lot higher. But it's just quite a nice check to see what's happening, see what regions you're in. So that pretty much is a quick summary of what it does. We've got different units here if you want to see what it's like in those old Imperial ones. And what you can do is you can run different tests. You can try different angles and get the results, and then you click here, you can actually see the results. So you can copy these. These are the results, these are the titles. You can just copy this and paste it into Excel, and then you can plot graphs for the different conditions and various things if you need to. You can select if you want a quote, but if this is the pro version, if it's just the free version, then it does send an email. You get the results, and it sends an email to potential suppliers in your area. But if you unlock it, you can select that and see the results. Just copy and paste. So it gives you a quick idea on what it would do. Be interesting to see systems designed in this and how they compare. But have fun.